is orange. And white light's hitting this blue gelatin dessert. But all we see is blue gelatin. On my coat, well, it's got lots of colors. Hey, it's the show about light and color. Now, without different colors of light, we couldn't see different colored things. And of course, without light, well, we couldn't have a TV show. Oh, funny. Oh, very funny. You can turn the lights on now. Turn the lights on.
Hey, you stepped on my foot!
Sorry. I got it. Now, this is the plastic water-filled prism of science. And shining into it is a bright white light. Now, when white light goes into a prism, it breaks up into all the colors of the rainbow, what we call the full spectrum of colors. So down here is the spectrum being made by the prism of science. See, here are all the colors of the rainbow: red, orange, yellow, green, blue, indigo, and purple or violet. Now watch. I'm going to try to break these colors up using another prism. Red, yellow, green, blue, and violet. See, they can't be broken up anymore. What that means is these are pure colors. White light is a mixture of all the colors of the spectrum, but each color is its own color. White light is colorful.
You can mix colors and get different colors. Here's how. Put some water into 3 empty glasses. Add red food coloring to one, blue to another, and yellow to another. Now, mix them together. Red and blue make purple. Yellow and red make orange. Yellow and blue make, hey, green. And all the colors mixed together make black.
What gives fruits and vegetables all their different colors?
I don't know.
Well, chemicals in the skin of the fruit and vegetable absorb and reflect different wavelengths of light. Take this orange. It's absorbing all the colors of light except orange, which it's reflecting. This green apple, it's reflecting green, absorbing the other colors. The red pepper, it's reflecting red and absorbing the other colors except red. Bet you didn't know I could juggle. I gotta do it for this bit. Gotta get these colors flying. Oh yeah, sure, there it is. Sure. Look at all those colors. It's chemicals reflecting and absorbing white light from the sun. What a party!
Party! Watch it, careful. Watch it. Ow,
London Bridge is falling down, falling down, falling down.
This car is red because it's reflecting red light. Now leave me alone.
Okay.
They're lined up to kick the extra point, and wait a minute, there's some kind of disturbance behind the end zone.
It's the Rainbow Kid, Lance, and as usual, he's holding up a sign.
White light is all the colors of light mixed together. You know, he's right about that, Timmy.
He certainly is, Lance.
Consider the following. There's an old saying in science: we don't see things. We see light bouncing off of things. So when you see my tie, you're seeing light from the lab that hits the tie and goes into the camera and works its way to your eye. Now, here in the lab, we have almost perfectly white light. We have almost all the colors of the spectrum. But when you look at my tie, it looks black with just a few brightly colored spots. What's happening to all the other colors? Where are they going?
I don't know.
Well, they're getting absorbed and turning into heat. You may have noticed this. In a bright light or in the sun, a black cloth feels slightly warmer than a white cloth. That's because the black cloth is absorbing almost all the colors of light that hit it and changing them to heat, whereas the white cloth is reflecting almost all the colors. This is how paint works. Paint absorbs light. Paint has little particles in it called pigment. So red paint is absorbing most of the light that hits it and reflecting red. Yellow's absorbing most of the light and reflecting yellow. And blue paint absorbs most of the colors and reflects blue. Now when we mix the colors of light, red, orange, yellow, green, blue, indigo, and violet, we get white light. But when we mix different colors of paint, it doesn't work that way. Red, yellow, and blue. And blue. The bottle's giving up.
Uh-huh.
And blue.
Okay.
And blue. When they're mixed, they don't turn white. They turn kind of a messy brown. That's because it's absorbing light. Well, there's a lot of things in nature that absorb almost all the colors of light that hit them. Like charcoal, or this dog. Well, thank you for considering the following.
One of the things I really like about neon is that it's a good incorporation of science and art. Okay, now neon tubes are different than incandescent bulbs. The neon gas is inside of it. Now the neon gas gets excited when it's charged with high voltage electricity and it pulses throughout the tube. Neon is really great in that there's a lot of different possibilities color-wise with it. Now the key is to heat up the glass evenly. Okay, this is getting pretty liquid. I'm attaching the electrode. Perfect. This tube has neon gas in it. You don't get the light and the color until you introduce high voltage electricity. You do have to be careful around neon because you're using high voltage electricity. You're using very high voltage in order to excite the molecules inside the tube. It's neon. It's light. It's color. It's science.
Lasers are beams of very intense light, but you can't see them till they bounce off of something, till they reflect off smoke or dust particles. The reason they put smoke in the air at dance parties is so the lights have something to bounce off of.
For about the last 17 years, I've been using lasers to do all kinds of laser light shows and laser displays. What we do is we take the laser light, the beam of light, and we can move it around very rapidly and precisionally and draw animations and forms, geometric patterns. Lasers are very powerful light. This laser is a couple of watts, and as you can see, it ought to be able to burn this pencil right away. Working with lasers, it's showbiz and it's science, so it's kind of a combination of both, and I guess that's what I like most about it.
Red things, like these red clothes, absorb all colors of light except red, blue, yellow, green. They reflect red light. White reflects all colors. Blue, yellow, red, green. Come on, hit me with all you got.
My pits are turquoise because they're reflecting turquoise light. Now leave me alone.
Okay.
Here's the windup and the pit. Wait a second. There's some kind of disturbance behind home plate.
It's that rainbow kid again, Lance. He's everywhere with those signs of his.
The color of an object is the color of the light it reflects. You know, he's right about that, Jimmy.
He certainly is, Lance.
Hey, science guy, why don't you show me what's in that piece of junk? Come on, let's go. Come on.
See, he thinks he's pretty cool, but he actually might be hot because he's in a black car. And black cars and black clothing absorb all colors of light and convert them into heat. Now, a white car, that's cool.
Come on, man, let's go. Come on.
Pretty hot, sir.
Yeah, but not as hot as my car.
Hi, I'm dressed in black because it helps to keep me warm. Black absorbs most of the heat from the sun and reflects very little. And when I wear white, I stay cool because white reflects all colors and absorbs very little. But you have to admit, even when Science Guy isn't wearing white, he's still pretty cool.
Uh-huh.
Yeah.
We all have rubber gloves on. Let's start by mixing the colors. Lavender, we did that one. You did
Oh,
too.
I have purple here. Tie-dye, it's cool.
Well, I'm adding orange, and I'm doing like red, orange, and yellow, kind of like the light rainbow colors. We are taking out the rubber bands, and we're gonna see what we got. We're awful tense because it's like a mystery to us. What is it gonna be like? It's totally groovy.
We can go surfing, dude. And look at them flying. Aren't they gorgeous?
Yes.
Light and color.
Inertia is a property of men. Well, that's so true. That's so true. Oh, boy. Hello, officer. Is there a problem?
Yes, Mr. the Science Guy. There is. Your taillight is out here in the back.
Oh, boy, I'm sorry about that. I'll get that fixed right away. It's funny that a light would be out because we're doing a show today about light and color. Yeah, see the guy with the camera?
I've heard that one before. Sure.
Yeah, see the guy with the camera?
Oh, yeah. Hey, could I ask you a question?
Sure.
What's the deal with the green lights and the red lights?
Oh, that's a great question. Because, you know, red, green, and blue are primary colors of light. And our eyes are especially sensitive to them, particularly green.
This guy really does know his colors.
Thank you, Mr. the Science Guy.
You're welcome, Officer 220.
And don't forget to get that taillight fixed.
Sure. That red taillight. Check this out. See the colors in the bubbles? Where do they come from?
I don't know.
The colors in soap bubbles come from light waves running into each other. No kidding. We can think of light as traveling in waves. Now, red light is long, slow waves. And blue light is short, fast waves. It's upside down, sorry. Blue light, short, fast waves. Now, when the light enters the skin of a bubble, most of it goes right through. But some of it bounces off the inside of the bubble and comes back toward your eye. And then we see colors.
There are a lot of colors in the big city. Most of the time, you don't think twice about it. And then there are times you can't stop thinking about it. My name is Luna Van Dyke. It's a Dutch name that means trouble. I'm a detective. It was a Saturday morning, and I was polishing my prism when he walked into the office. My nephew, Davy.
Aunt Luna, why is the sky blue?
Of all the questions in all the sciences, he had to pick this one.
Wait here, kid. I'll be right back. Hey, why is the sky blue?
I don't know.
Hey, why is the sky blue? Why is the sky blue? I don't know. Hey, why is the sky blue?
Well, what'd you find out?
The answer's right under our nose, kid. The sunlight looks white, but notice what happens when you bend it with this prism.
You get a whole lot of colors. They bend as they go in the prism. Blue light is bent a lot more than red.
Bingo. Air molecules in the sky scatter the sunlight. Blue light gets scattered a lot more than red, so blue is what we see.
Wow!
Come on, kid, I'll buy you a Cocoa.
Luna Van Dyke, presented in black and white and blue.
On a sunny day, light from the sky reflects off the water. The sky is blue, so the water is blue.
Hi, my name's Jandon. I work at the Crayola factory, and my job involves the science of color. It's all about the theory of color mixing and just incrementally getting smaller and smaller distinctions between colors, but they're still visible. You can still see the visible difference between them. This is a dye. This is a pigment. It's a dye, it's a pigment. Pigment, it's a dye. Art, and it's science.
Red, orange, yellow, green, blue, indigo, violet. Roy G. Biv.
My coat is black because it's absorbing almost all the light. Now look, I warned you.
It's extremely important that he gets his first serve in here because... Oh, wait a second. There's some kind of disturbance behind the far line, Judge. No, it couldn't be.
It is, Lance. It's a crazy rainbow kid again.
White objects reflect all colors. Black objects absorb all colors. You know, he's right about that, Timmy.
He certainly is.
Is a rainbow cleverly disguised, reflected by an object that bounces to your eyes. Whatever colors are absorbed are colors we don't see. But the color that bounces off is the color we perceive. If you've seen the color white, then you've seen all there is to light. And if you've seen the color black, you've seen light absorb, not give them back. Light, color, talking about the spectrum of the light. Color, talking about the spectrum of the... And what happens to the colors that get absorbed? Well, light becomes heat and things get warm. If there were no light, there'd be no color. then our world would be a whole lot duller. If you've seen the color white, then you've seen all there is to light. And if you've seen the color black, you've seen light absorb, not get that back. Light, color, talking about the spectrum, brother. Light, color, talking about the spectrum, brother. Light, color, talking about the spectrum, brother. Light.
It was fun hanging out with you today. I hope you found today's show enlightening. Anyway, if you'll excuse me, I have got some wavelengths of light to mix and reflect. See you around. See you next time there's light bouncing off you. Moon, indigo.
Produced in association with the National Science Foundation.
If you see a riddle in here, it's a fact you should know it's just for lights. Just for lights. Baby, it's so easy and the colors are so easy. It's just for lights. Just for lights. A rainbow is just for lights. Just for lights. A rainbow is just for lights. If you see a riddle in here, it's a fact you should know it's just for lights. Just for lights. Baby, it's so easy and the colors are so pleasing. It's just for lights. Just for lights. A rainbow is just for lights. Just for lights. A rainbow is just for lights.
Thank you.